This is Physics 2, Lab 2, Lines of Charge. Introduction. In this experiment, using data from my previous experiment with floating pieces of charged tape, I modeled the electric and gravitational force on them, this time distributing the charge evenly across the length of the tape. Some of the key concepts in this lab are the interactions between atoms, Coulomb's law, polarization, the electric field of a charged rod, and the relationship between the electric force and field. Here are some important formulas. Assumptions. We can assume both pieces of tape have the same mass and have the same charge. We can also assume that the charge is distributed evenly throughout the length of the tape. The force from air resistance is ignored, and gravitational force is equal to electric force, which means that the net Y component, because of the net Y component of the force on the tape is 0. My experimental data and results are the same from the last experiment. It'll be used later in my my code. So for my code, I initialized the K constant, the charge for proton, the mass of the tape I calculated, and the Y component of the distance between the two tapes. The for loop in this code models the formula for calculating the electric field of a charged rod as it progressively adds up the electric field dE for each point charge dQ. The E scale and FE scale were both found through trial and error. So I'll go ahead and show my code. So here's my code right here. This is where I initialize the values. This is where I define the formula for the electric field to be used later on in the for loop. There is the E scale and the FE scale. This is the for loop that I was talking about. And this is where they calculated the electric force using the electric field. And it looks like this. As you can see, the electric force and gravitational force are both equal in magnitude, roughly. So what if the estimated value of the tape's charge using the point charge model is 9.33 times 10 to the negative 9th coulombs, and for the line charge model is 7.15 times 10 to the negative 9th coulombs. I found the second value through trial and error. Originally, I used the charge from my experimental data, but the gravitational electric forces weren't equal in magnitude. So I plugged in the values for Q into the magnitude electric force was about equal to the magnitude gravitational force. Why? In the first experiment, we ignored the forces in the x direction. However, in this experiment, both the x and y components were included in the forces. This, as well as using multiple infinitesimally small charges, makes my second value more likely to be closer to the real value. Thanks for watching.